All right, so we're gonna do a 3.2 trigonometric integrals. So we have number 1, number 2, number 3. It's all about cosine and sine. Which one we can do by use of? Which one we cannot by use of? Which number? So quiet today. So number 1, number 2, we can. Too late. Time's up.
My guess is number 3, maybe.
Yeah, we cannot integrate by use of number 3. Okay, so we can integrate by use substitution, number 1 and 2, but not 3. Then we're gonna use trigonometric integrals in this title. Okay. All right. So we have a strategy. Let me write down. Why should I use this one? So that we can do this one later on. 3. So if sine is odd power, sine is odd power, then we split off. Then we're gonna use sine squared x equal to 1 minus cosine squared x. This is come from Pythagorean identity. So we have Pythagorean identity. Cosine squared x plus sine squared x equal to 1, right? Now, if we have cosine is odd power, then we split up. Then we use cosine squared x equal to 1 minus sine squared x. Same as from the Pythagorean identity. Okay, cosine squared x plus sine squared x equal to 1. All right. One more. If cosine sine is or even power, then we are using sine square x equal to 1 minus cosine 2x over 2, which is half angle formula from pre-calculus trigonometric. And cosine square x equal to 1 plus cosine 2x.
Is that 1 minus cosine 2x or cosine squared x?
Cosine 2x.
Oh, okay, cosine 2x. All right.
Thank you for checking it out.
But why actually we divided by 2? What's the reason for that?
Oh, I have to prove.
I got a point. Never mind.
Yeah, I have to prove from the trigonometric course,
Yeah.
right? Yeah.
I got the point.
Okay. So this is from the pre-calculus. This is from the trig, right? Okay. So if you want, I can explain to you later on after this lecture. All right. Okay, I want to focus on our section, which is Calculus 2, which is trigonometry, the integrals. All right. So we are using this one. So for now, then if there is more than this, I'm going to explain to you more. Okay. All right. Sine is other power. We split off. We don't know how to split off, but we have to use sine square x, which equal to 1 minus cosine square x. Then cosine is other power. We split off. Then we are using cosine square x minus 1 minus sine square x. Okay, even power. Then from pre-calculus or trigonometry subject, we are using half angle formula. This is a formula actually, right? Okay, then we have a sine square x equal to 1 minus cosine square x over 2. All right. Okay. Oops, we don't need that. All right, so we're gonna start number 3 in this case. So integral of sine to the third power x and cosine for x, fourth power x dx. Okay. So by the way, quick one. So number 2, because we don't have to deal with the sign, negative sign, positive sign. So number 2, quick, what do you get this one? So derivative of sine, we have a cosine x, right?
Yeah, cosine 3x.
Yeah, so then we are dealing
minus
with
sine
only the
6.
power. So we are dealing with only the power. So we're gonna have a sine to the fourth power x over 4 plus c. Okay, this is by use of. I explained to you this method yesterday. So I posted on the announcement this method. Please watch that. All right. So then number 3. So we have integral sine to the third power cosine to the fourth power dx. All right, so is it sine has other power, cosine has other power? Hard. Oh, other means 1, 3, 5, 7, 9, 11. So which one has other power?
4.
Other power? Other power means 1, 3, 5. 7 is other power. So sine has the other power. Make sense? All right, so then we are using this strategy. Sine is other power, then we split off. We don't know how to split off, they say that, but we have to use this one, right? Then let me show you how to split off by using this one. This is come from Pythagorean Identity, all right? Okay, so look, we have to have sine square x. Do you agree? So 3 power, yes, good. And we split off this way because we have to make a sine square x, right? By strategy. Now we have cosine to the fourth power, excellent, x dx. Okay, now your classmate said that we're gonna use 1 minus, which is this one, right? We are using this one. 1 minus cosine square x Then we have sine x and cosine to the fourth power dx. Okay, now I want to switch in order. Okay, it's a multiplication, we can do that. So we will have 1 minus cosine square x, then cosine to the fourth power, and sine x dx. Okay, now we do distribute. So we will have cosine to the fourth power minus cosine to the sixth power, and we have sine x dx. Now, can you see that? We can distribute. So we integrate, we have cosine fourth power sine x minus cosine to the sixth power and sine x, and whole thing is dx. Okay, now we have two terms, so we want to integrate term by term, so we make it this way. All right. How do we integrate this one? Okay, how about you, sub? What do you want to set up as u?
Let u be cosine, the
Cosine.
first part.
Yeah,
Cosine.
cosine, excellent.
Yeah.
So we're gonna do cosine. So cosine x, then derivative, what do you get?
Sinus. Oh,
Negative
minus
sin x.
sine, negative
Okay.
sinus.
Excellent. Now we don't have a negative sign in here, right? Can you see that we don't have a negative? So we do divide by -1. So we have negative du equal to sine x dx, right? All right. Then this will be, look, we have u to the fourth power and negative du. We can just use the power rule, right? So what again? We do it, integrate u to the fourth power.
Sinus 4x.
Oh.
Right?
Oh, integrate, sorry.
Yeah. I know we get confused. We had confused yesterday too. So u was the cosine, right? So we can just use, look, put the negative sign in this case, and cosine to the 5 and over 5. Now, we noticed this part, oops. We noticed this part too, right? What do you get? Integrate. It's very similar with this one.
It's similar, it will be the same, but with
Yeah, just using power
making
rule.
the substitution from
Yes,
5 to just 7.
7. So we have to have a negative. So it will be positive, right?
Yeah.
So it will be positive and cosine to the 7 power over 7 plus c. So is it okay?
Looks good, but
Oh, that's good. All right, now let's move on. Now we have sine to the fourth power, cosine to the fifth power dx. Okay, which one has other power?
Sine.
Cosine, yeah.
Cosine, good. So cosine has other power, then look, they say that strategy said that we're gonna do split off, then we are using this formula when cosine is odd, okay? Then look. We're gonna for sure cosine square x, then cosine third power, right? So let us do that. Okay, but then look, instead of I want to do this one, I want to do this way. Look, I want to do 1 cosine fourth power cosine x dx. So we split this way first. Then we're gonna make the form. So look. And fourth power. So cosine second power to the second. So do you agree? I made cosine fourth power x cosine square x over, not over, squared. Is okay? Say uh-huh.
Uh-huh.
Okay, good.
Looks good, actually.
Uh-huh. Okay, then look, we will do, now we're gonna use Pythagorean identity for this one. Okay, so this will be 1 minus sine square x, but then don't forget we have a square, the power, so we have that, and cosine x dx. Then I will use a minus b squared, which is a squared minus 2ab plus b squared. So this will be sine to the fourth power 1 squared minus 2 times a times b, which is 2 sine square x plus sine to the fourth power and cosine x dx. Okay, now let us distribute. So we have sine to the fourth power minus 2 sine to the sixth power plus sine to the eighth power and cosine x dx. Okay. Then distribute again. So we will have sine to the fourth power cosine x. Okay, since we have experience in the exam number 1, so let us integrate term by term. So I want to make this way. And we have 2 sine to the sixth power cosine x dx, no space, sine to the eighth power, sorry, cosine x, oh my God. Sorry about that. Little bit. So this is cosine x. All right. Okay, sine to the fourth power cosine x. Let u equal to u sub. What do you want to set up as a u?
Let's do sinus.
Thank you. And derivative of sine x, what do you get?
Cosine.
Cosine is
Excellent. All right, then we have u to the fourth power du. Then we can just do using antiderivative of power rule, right? So what do you get?
U to the
5.
5/5.
Excellent.
Yeah.
Okay, now u is the sin x. So we substitute back. So it will be sine to the fifth power over 5 minus, we have a 2 there. Look, now we know that we just dealing with the power, right? What do you get? Antiderivative of this. So integral of this, what do you get this one? 7, good. So we get 7, good. So oops. What about this one? Integrate this power. We already had a u sub is 9, good. So positive plus c, okay? This is how we do.
Should there be an x there? Sine 9x?
Oh, thank you so
or no?
much. Yeah, good job. All right. Now, what if we have even? So look. Okay, so this is even power for the sine, also even power for the cosine. Then look, they say that we're gonna use this one. Okay. This is a half angle formula from trig. So let me write down here. All right. Now look, do you agree this one I can express as sine x cosine x squared? Do you agree?
yes.
Yes, good. Now then, do you remember we have a double angle formula from trig? So we have a 2 sine x cosine x, which is sine 2x. Okay, look, then we don't have a 2 there. Can you see that? Here is a 2, but we don't have a 2 here. So we divide by 2 there. So we will have 1/2 sine 2x. Let me write down here. So 1/2 sine 2x 2 dx. All right, now 1/2 square, which is 1/4. I want to take out from the integration symbol. So it will be 1/4 sine 2x. I want to write down this way. How about that? Okay, now, can you see that? We have sine square x dx, not dx, sine square x equal to that. Yeah, but then look, x corresponding to x. So we're gonna make 2x as 4x. Yes, excellent. Okay. So we're gonna do that. So look, 1/4 and 1 minus cosine. Let me make a little bit bigger so that you know that we're using 2x to corresponding 4x and over 2. Okay, and dx. All right, this is a constant. So we can take out the from integration symbol. So we have 1/4 and 1/2 and 1 minus cosine 4x dx. Now we integrate term by term. So that will be 1/8 whole thing, right? Then 1 times dx minus cosine 4x dx. Okay, what do you have? First term. X, very good. Okay, second term, we did that yesterday. So integrate cosine 4x. Okay, you forget already? Okay, let us do that. Let u equal to what?
Minus.
4x. Okay.
Oh, 4x.
Mm-hmm. All right, then derivative, what do you get?
4.
4. And we don't have a 4, so we divide by 4 both sides. So it is 1/4 du, which is dx. So we will have cosine u and 1/4 du. So we antiderivative of cosine u, what do you get?
Negative
U.
sign.
Sine U.
Just a sign, right? Antiderivative. Yeah. So look, then in this case, we have 1/4 sine 4x plus c. Okay. Now 1/8x minus 1/32 sine 4x plus c. Okay.
Where is 32 coming from? And
Which one coming from?
the 32?
32. So I multiply 8 and 4. Yes.
Yeah, but on the bottom, do you
Okay.
have to put, do you put it twice? I mean, again on the bottom, 8
Okay.
Okay.
All right. Okay, now, if, so we deal with, if a sine is odd, cosine is odd, we're using the strategy, right? If sine is even, cosine is even, we are using like this, using half angle formula, right? Now, if sine or cosine is only single, then there is a reduction formula, much easier. So I'm going to introduce the reduction formula here. Okay. So we have sine n power x dx. Then they have a -1 over n. Sine n minus 1 x cosine x plus n minus 1 over n. And integral of sine to the n minus 2x dx. Okay, we have a cosine x dx equal to 1 over n cosine n minus 1 x sine x plus n minus 1 over n integral of cosine n minus 2x dx. Okay, all right. So let us do this one. We cannot integrate this one by using new stuff, right? Then this one is a single, so we can use a reduction formula. So I'm using that. So n equal to 2 in this case. So look, I'm using this one. So minus 1 over 2 sine 2 minus 1 cosine x plus 2 minus 1 over 2 integral of sine 2 minus 2, right? Okay, then -1/2 sine to the first power x cosine x plus 1 over 2. 2 minus 2, what again? 2 minus 2? Hardest problem, huh? 2 minus 2. 0.
Zero.
Good. Very good. Then sine x cosine x, good, plus 1/2. Okay, so what's the 0 power is it telling us?
1.
Thank you. What is the integration of 1?
S.
X, good. Plus C, okay. Easy, right? Just apply the formula. All right, we have one more for cosine. Cosine.
Professor, I have a question. So the one on top you wrote, the first one, they are just formulas? Or what is?
Yeah, it's
Oh, okay.
they called reduction formula. Now, you don't have to remember anything, okay?
Okay.
Yeah, especially this is an online course, right? Yeah,
Okay, so
you don't have to
so there's
remember
no-
anything. You must remember the basic stuff. What's the antiderivative of cosine, sine, like trig functions, basic stuff you learn from the Calculus 1. You must remember, right?
Sure.
Yes. Probably IBP we learned the last time, but you don't have to remember, right? Okay, just to know how to apply.
Actually, me and Joe, we were in the same Calculus 1 class, and I
Uh-huh.
think we could send some really good like formulas list which we had from this class. I think it will be in our study group. So
Oh, yeah, that's good. Yeah. Okay. Keep working. Good. So we have a reduction formula. You don't have to memorize it at all. If you have to memorize, I'm going to tell you, oh, you must know this one. All right. Okay. Now we have cosine to the fourth power. This one. I'm using the formula here. Okay. So I want to move a little bit down so that you can see that. So 1 over n, which is a 4, cosine 4 minus 1 x, sine x, plus n minus 1, which is 4 minus 1 over 4, and cosine 4 minus 2 x dx. Okay. Now, let me make a detour, and then I'm gonna write down the end nicely. We have 3 over 4, and we have cosine second power dx. Okay, now we cannot use sub, so we can just use reduction formula again. So reduction formula said that, let me make a shrink so that I can see that d2 plus 3 over 4, 1 over n, in this case 2, so 1 over 2 cosine 2 minus 1 sine x plus 2 minus 1 over 2, and cosine 2 minus 2 x dx. Then it must be the last integration power 2 minus 2, right? Then we finish. Otherwise, we do reduction formula, using reduction formula again, right? Okay.
are there any possibilities that the reduction form could be infinite? That we always will have the endless process of reduction.
If there is a too big for the n, they probably don't give it to us.
Okay.
Yeah. So cosine 3x plus distribute, which is 3 over 8 cosine first power sine x, and plus distribute 1 there, which is 3 over 8, and 0, which is 1 times dx, right? So we have experience. So we get x, right? Plus c.
Professor, I have a question.
Mhm.
You did after 1 divided by 4 cosinus 3x, should we plug sinus x as we did in the first like stage of the solution or not? While
Okay,
we don't
so
have sinus x.
sine over 6x. Sine over 6x
Is sin x just after?
is what?
No, I mean like in the first part.
First part?
Yes, this one. This sinus is goes. Okay, I think I got it. Sorry.
So hold on 1 second. Let's see. We have a sine x. I just copy down.
Yeah, okay, thank you.
Okay. All right. One last one for sine and cosine. Okay. What if we have a different angle? Integrals involving sine, cosine products with different angles. All right. So look, sine alpha, this is also from trig, cosine beta equal to 1/2 sine alpha minus beta plus sine alpha plus beta. Okay. Now we have there's more, huh? Sine alpha, sine beta, which is 1/2 cosine alpha minus beta minus cosine alpha plus beta. Another one, cosine alpha cosine beta equal to 1/2 cosine alpha minus beta plus cosine alpha plus beta. So your professor probably taught you, oh, you don't have to memorize anything, right? Yes. Okay, how to apply, know how to apply. All right. So in this case, we are using this kind of integration. Look, if we have same number in this case, which is the same angle, we can integrate by use of, okay? Since this is different angle, different number here, so that we cannot use of, all right? So then we are using this formula, different angle, okay? So this is a product of, since different angle, we're gonna look for sine alpha, sine beta, okay? The first one, we're gonna use that. Make sense? Say, uh-huh.
Yes.
Okay.
Yeah, I agree.
All right. So I just follow this one, okay? Look. One half. Sine alpha. So let's see. Alpha equal to this. And beta equal to that. So alpha minus beta plus sine alpha, which is 5x, plus beta, which is 4x, and dx. All right, then let's take out the 1/2 because constant. Now we can calculate 5x minus 1x. What do you have?
Yes.
Just
Yeah.
x.
Yes.
Good, thank you. And we have
Sine 9x.
9x.
my next excellent. So since we have two terms, so let us save the one step. So that plus sine 9x dx. Okay, now we integrate sine x, very easy. Antiderivative of sine x, what do you get?
Negative cosine x.
So we have a negative 1/2 negative cosine x, right? Now, antiderivative with sine 9x. We have experienced cosine 4x like that too.
One
just like-
over nine.
Yeah,
Okay,
yeah. 1
someone
over 9.
said something. 1 over 9, good.
One
Yeah.
over nine
And anti of sine, which is
negative cosine
negative
is-
cosine. Good. So we will do that. Plus C. Oh, I forgot now. Distribute. So we will have
1 over 18.
18. Good. Mhm. Thank you. All right, good job. I'll do one more time. We have used up. We have sine 9x. Then let u equal to 9x. du, which is 9 dx. We don't have a 9 there, so we divide by 9 both sides. So this will be, okay, you got it? All right. So sine u du. That's how we got it, okay? Yeah. 1 over 18, look, we have 1 over 9 there, right?
And
And
why
I forgot-
negative? I'm sorry, why negative? Negative.
Why
114.
negative? Because
Wow.
we have, okay, back to the this one then. Antiderivative of you guys make me crazy. Hold on 1 second. Let me clarify this one. Okay. Since this is YouTube, I cannot call your name. Someone who just asked me how we get the 1 over 9. This is how we get the 1 over 9. Look. We don't have a 9 there in this case. Yeah. So we have 1 over 9. Then we have 1 over 9. Hold on 1 second. Raise your hand. So 1 over 9. What's the antiderivative of sine?
Just cosine.
Antiderivative of sine
Negative.
means that
Cosine.
something derivative, then we get the sine. What do you get?
Negative cosine.
Yeah, negative cosine. Yeah.
Oh, negative. Yeah.
Yeah, so that's why we have a negative cosine. Okay, so your question clear?
Yes, thank you.
Okay, good. So who got the in the chat? Your 1 over 9 is clear too? Okay, you raise your hand. So please let me know your question. Raise your hand. Okay then. All right. Wow, it's a 50. Oh, wow, we have to do a lot of things too. Okay, before we get into the secant and tangent, we have to know about this one. So this is a basic integration. I believe you learned from the Calculus 1. This is What do you get? This one? Number one. So think antiderivative. So what's the derivative? Make a secant square x. Woo!
Uh,
It's a
Tangent
tangent
x.
x. Yes, thank you. How about this? Number two. Think what derivative will make us
Secant x.
secant x. Excellent.
secant x.
Then there's one I can secant square x.
Secant x, 10x. Good. All right. So this is a special one, so you might not remember. Okay, this one's special.
That's secant square x? No.
This one I can just quickly prove for you. So this is tangent, which is sine x over cosine x dx. All right, then let u equal to cosine x. What's the derivative? What do you get?
Negative
Negative sine x, excellent. Look, we don't have a negative sign, so we do divide by -1 both sides. So we have negative du, which is sine x dx. All right, then we get negative du over u. So what do you get this one? We did that yesterday a lot.
Ln x.
Ln x, good, ln u, right? So negative ln u. Look, ln u is negative ln cosine x, okay? Then look, we have a negative. This one is, we can make here, yeah. Then we have a negative power, then we can set 1 over secant. Yeah. 1 over cosine, 1 over secant, 1 over cosine, 1 over cosine, which is ln secant, right? So this is ln absolute value of secant x, okay? So in your formula sheet, there is integral of tangent x dx, which is equal to ln secant x plus c. Or some book indicate that negative ln absolute value of cosine x plus c. Okay, so either one. All right, now let me prove this one. So we have a secant x dx, then I want to multiply secant x plus 10x. So we will have distribute secant square x plus secant x 10x over secant x plus 10x, right? All right. Now let's let u equal to secant x 10x. Oh, secant plus 10x, sorry. All right, derivative, what do you get? turn by turn. What's the derivative of secant?
Of secant is will be secant x tangent x,
Excellent.
or
Yeah, what's the derivative of tangent x?
secant.
Secant x squared, right?
Yeah,
As
yeah.
we did earlier. Now, look, dx. We have everything there. Can you see that? So it will be du over du, right? So what do you get this one?
ln.
ln. Very good. So this will be ln, and u was secant x plus 10x. All right, proceed. So you should know this one. Okay, now we are going to do the related with the power, with the secant and tangent. So let me write down strategy for you. Integrals involving powers of secant and tangent. All right, so secant is priority is secant is even power. Then we split up. Then they give us split off as a secant square x. Then we use secant square x equal to tan square x plus 1. Okay. And second one, tangent is other power. Then we split off to secant x, tan x. Then we are using, this is another Pythagorean identity, right? So tangent square x equal to secant square x minus 1. And then this one comes from this one, right? Okay. Now, third, secant is odd. Then use IBP, integration by part. Okay, so this is what we did, 3.1. Okay, all right. So let us do this one. Tan square x secant to the fourth power dx. Look, secant is even, right? Then we're gonna split off secant square x, then we're using this, okay? All right. We have a tan square x, we do secant square x dx, okay? Now, we are using tan square x plus 1 and secant square x dx. All right. Now we do distribute. So we have tan square x, sorry, fourth power plus tan square x. Then we have a secant square x dx. Now we have an experience, so let us integrate term by term. So let us make this one 10 to the fourth power secant square x plus dx. tan square x secant square x dx, right? All right. Look, let you sub. What do you want to set up as u?
And
Tangent, excellent. Tangent x, then du, which is
will be secant
square
to
x.
second x.
Good. Okay. Look, we have everything there. Can you see that? Secant square x. Now we can just deal with the power, right? So u to the fourth power du, then we know that. So this will be 10 to the fifth power over 5. What about here?
It
Hello?
will be just 3.
3, thank you. Plus C, okay.
Why we divide by 5 there?
I'm sorry, 3. Thank you so much. It's a 3. Yeah. Okay, now we have tan cube secant cube dx. Okay. All right. Since we have a second priority, tangent is the power. We're gonna split up secant x tan x. Then we're gonna use tan square x equal to secant square x minus 1. All right. Let us do this. Secant square x here. All right. So look, we will make, let me see. This is tan square x. Then we have one left, so we can make that. Then we have to make from cube. We're gonna make a secant, and then secant square x dx. Can you see that? Now, this one, we're gonna use Pythagorean identity, and I want to use the changed order, secant s, tan s, so that we can see easily. So we have secant x minus 1 and secant x, tan x, secant square x dx. Oops. Okay, now I want distribute this one, okay, with that. So this will be secant to the fourth power minus secant square x. Then we have a secant x, tan x. Now, let us make a term by term for the integration. So we have a secant to the fourth power, secant x, tan x, dx, minus secant square x, secant x, tan x, dx. All right, so we have experience. So antiderivative of secant to the fourth power, what do you get?
as an derivative?
Integration.
Oh.
Five.
Sec to the fifth divided by
Yes,
5.
secant to the fifth power, because we have derivative of secant x, we have a secant as 10x. So that we can deal with only the power. So we will have a secant to the fifth power over 5 minus, and same as here, we deal with the power, which is
Secant to the third divided by 3.
excellent. Plus C, okay. Very good. Okay, now we're gonna use the reduction formula for this one too. So this will be last one. Reduction formula. Let me just write down secant. Secant and tangent. All right, so we have secant to the n power. And we have 1 over n minus 1, secant to the n minus 2, 10x plus n minus 2 over n minus 1, integral of secant n minus 2x dx. Now we have 10 to the n power dx equal to 1 over n minus 1, 10 to the n minus 1x minus 10 to the n minus 2 x dx. Okay, so let us do just tangent, since we don't have time, because tangent do twice this way. All right, so I'm gonna
So
use.
it's all based on the reduction formula. We're like implementing reduction formula into the real case.
Yeah,
Okay, nice.
yeah. So we have 1 over 4 minus 1, 10, 4 minus 1 x minus 10, 4 minus 2 x dx. So let me make a detour. Okay, since we cannot integrate this one, we're gonna use the reduction formula again. So let me make a detour, and then 1 over n minus 1, so 2 minus 1, 10, 2 minus 1, minus 10, 2 minus 2 dx, right? And d2 minus, it's 1, so 10x minus 10 to the 0 power. We have experience 0 power. Let me write down 10x. Let us do it later. Minus, which is 1 times dx, d2, minus the 10x minus x dx, not dx, right? Plus c. So let me arrange everything. So it will be 1 over 3, 10 to the third power, minus tangent and plus x plus c. That's it? Wow. All right.